Have you drawn this?
Yes.
So for example, you have a voltage source here connected at this end with two resistors R1, R2 connected in series. They have different what? Voltages. Resistors in series have different voltages for the same current. Yes or no? If I'm wrong, call me back on. So they have the same current and what? Different voltages. So to make it easy to calculate the voltages across them, you can use the voltage divider rule. And what does it say? So to find V1 using voltage divider rule, V1 will give us what? V, the total voltage across V times 1. We want to V1 is going through what? R1, right? So you have R1 over the total resistance R1 plus R2. That will give us the value of V1. And V2 will also give us what? V2 equals to what? V times what? R2, because V2 is going through R2. R2 over what? R1 plus R2.
On the quick, the voltage divider rule does it really work for only series or for parallel?
Only when you have resistors in series. Actually, you can use voltage divider rule. Because that's when they have different voltages. If you have resistors in parallel, they have the same voltage but different current. So there's no way you'll be dividing voltage. So this also makes network analysis easier. If you want to find voltage across one resistor now, you can just quickly do this. That's given that the resistors are in series. If they are not in series, it won't work. So this voltage divider rule. Can we move on? Can we move on? Do we understand? So if I have, for example, now, okay, let me see how and here I have 5 ohms, and here I have 10 ohms, and it says V0 equals to 10. Find V1 and V2. What will be my answer? Using voltage divider rule. So they've given us R1 as 5 ohms, they've given us R2 as 10 ohms, and my V0 is 10 volts. So what will be V1 and V2?
That's 10 times, that's 5 over 15, that's 1 over 3, that's 10 over 3, that's 3.33.
3.33. Yeah, when you get one, since they are just 2 resistors, subtract this one from the other one, you get your V2. Did we get it? Now we continue. So we've gotten it. We all get it. That's voltage divider. Then number 3, we have current divider rule. Current divider rule. CDI. So giving current So you are given a current source, if not necessarily a current source, a voltage source, and then you have your resistors in parallel. When resistors are connected in parallel, you have the same voltage but different currents flowing through them. The same voltage or different currents flowing through them. Then how do we know the current flowing through R1 and the current flowing through R2? We can use what? Current divider rule. What does current divider rule say? It says that what? Let's denote this as I1, I2. So it says that what? I1 equals to what? I, the total current, times I1 is flowing through what? R1. But now you are multiplying it by what? R2 over R1 plus R2. To get I1. To get I1, the current flowing through R1, you use the second resistor. You know, in voltage divider rule, you use the first resistor. When you are looking for I1, you have R1 up here. But in current divider rule, when you are looking for I1, you use R2 up here. Why when we want to get I2 now? I2 will now be what? I2 will be what? I times R1 over R1 plus R2.
It's opposite of voltage
Yeah. Because the resistors are connected in parallel, not in series. So that's current divider rule. So you have your, when you are looking for I1, you have your R2 over R1 plus R2. When you are looking for I2, you have your R1 over R1 plus R2. That's current divider rule. So if I'm giving my I, say 7 amps, and my R1 is 4 ohms, my I2 is 3 ohms. What will be my I1 and I2? I is 7 amps. Yeah, I is 7 amps.
You say the R2 is what?
That's
R2
7
is 3 ohms.
and okay, that's 3 all over
I is what? 7. I is 7.
Nice.
I1 is 3, then I2 is 4.
Yes, I1 is 3.
Did we all get it? So you have 7 times 3 over 7 for I1. And you have 7 times 4 over 7 for I2. So I1 is 3 and I2 is what? 4. So that's simple as that. So when you are doing circuit analysis, instead of you doing equivalent of this, looking for this, are equivalent. So your current divider rule will just make it easy for you. So do we get it? Can we move on?
Yes.
Can I rub it off? Can I? Yes.
Not doing it, just doing
So the next one we have is what?
yeah, those are flowing.
KVL.
Because you stream, you need to give the camera brightness.
Let's work with KCL.
You can see far better with it.
KCL. I hope we know that KCL is different from nodal analysis. Is there any difference between KCL and nodal analysis? Is there difference? Are you sure?
I thought it's 3.
And now, this is 4.
Is it the first one?
Yeah, VDR. So is there difference between KVL and KCL and nodal analysis?
Yeah.
Is there difference? What's the difference?
This one is the one that is entering and coming is equals
The same
to
current that is going in, the same current. Same current going out.
So what
No,
was
it's not
nodal
there.
analysis? What's nodal analysis?
that means a closed loop around the
It's close to.
The division of current.
You are not answering like we are sure. If you are sure, give me answer. Is nodal analysis different from KCL?
Yes.
We say yes. So what's the difference?
Okay, this one
Yeah, that
is
is you can't get like
I'll upload it on something.
okay. It's not
you can use KCL.
But when you are solving nodal analysis, you are
not
doing I in, I out, and that's the same. So is there difference? So nobody can do.